Good morning class and welcome back. So in the previous class we have studied about the closure property with respect to integers, closure property with respect to rational numbers. Now again we are going to study the second property of rational numbers, that is commutative property of rational numbers. Alright, so in the previous class we completely studied with respect to integers and rational numbers. In this class as well, first we will study with respect to integers and then we will study with respect to rational numbers. Alright, so first let's get started. Commutative property. Commutative property's formula is nothing but a plus b. This is for addition, okay? So we are going to study commutative property in terms of addition. That is all the four basic operations: addition, subtraction, multiplication and division. Let us see if it is valid for all of these cases or not. Okay, so the formula is a plus b should be same as b plus a. Okay, so a plus b on my left hand side of the equal to sign. So this is equal to sign, correct? So the left of the equal to sign is called as left hand side. This is our left hand, right? So the left of is equal to is called as left hand side, and the right side of equal to is called as right hand side. All right, RHS or right hand side. So therefore, first we will see commutative property for addition, then we will go for subtraction, then we will go for multiplication, and then we will go for division. Now I am talking with respect to integers, okay? I am talking commutative property with respect to integers first, and then I will teach you commutative property with respect to rational numbers. Alright, so first thing is, when I am talking about addition of rational numbers and commutative property states that a plus b is same as b plus a. So a plus b, let a be any integer. Okay, here I have taken a to be 2 and b to be 3. So a plus b is equal to b plus a. Now 2 plus 3 should be same as 3 plus 2. Yes or no? Now see, 2 plus 3 is 5 and 3 plus 2 is 5. So LHS is same as RHS. So therefore commutative property of addition is valid, right? So what number I have on my left hand side, the same thing when I do it ulta. See, instead of writing a plus b, I got b plus a, right? So again I got 5 is equal to 5. So left hand side is same as the right hand side. Alright, so therefore commutative property of addition states that a plus b is same as b plus a, where a is equal to 2 and b is equal to 3. So 2 plus 3 is same as 3 plus 2, and 2 plus 3 is 5 is same as 3 plus 2 is 5. So 5 is equal to 5. My left hand side is same as my right hand side. So therefore commutative property is valid for addition. Now let's check commutative property for subtraction. Okay. Now the formula is, see, here instead of plus we will write what? Minus. See children, again I am telling you, this I am talking for integers. I have not yet started for rational numbers. Okay, we are just seeing. That means I have to get an integer. Let me see. Alright, so subtraction. The formula is, first for addition was a plus b should be same as b plus a. Now for subtraction it is a minus b should be same as b minus a. So the formula is, instead of plus, a plus b is equal to b plus a, I will write a minus b is equal to b minus a. Now let a be equal to 5. I have taken one integer 5. And b is equal to 6. That is one more integer 6. So according to the formula of commutative property of subtraction, a minus b should be same as b minus a. So therefore, what is a? It is 5. 5 minus 6 should be same as 6 minus 5. So therefore, 5 minus 6 is what? It is 5 minus 6, I will subtract it is 1 and put the greater number side. Here greater number is what? 6. And what is the sign of 6? It is minus 6. So my answer also will have a negative sign. Alright, so 5 minus 6 is nothing but minus 1. Now, when I am seeing D minus A, D minus A is nothing but what? 6 minus 5. So 6 is the greater number here and it is having plus sign. If there is no sign before 6, it is assumed always to be positive. So it is plus 6. So plus 6 minus 5 is nothing but what? Plus 1. Correct? You have all studied this from grade 6 onwards. So here, can minus 1 is same as plus 1? No, minus 1 is not same as plus 1. So thereby here we can conclude that commutative property of subtraction is not valid or subtraction is not commutative, because my left hand side I have got minus 1 but my right hand side I got plus 1. So then minus 1 cannot be same as plus 1, thereby it stands invalid. Therefore left hand side is not equal to right hand side. Alright, so here we have completed addition of commutative property in terms of integers for addition, commutative property in terms of subtraction for integers. Now let us see for multiplication and division. Yes, children. So in the previous class, we studied about the closure property of integers in terms of addition and subtraction. Now we will look onto the closure property of integers in terms of multiplication and in terms of division. Alright. So first, let us see. I have taken A to be 2 and B to be 3. Now what is the formula for closure property of multiplication? It is, instead of addition, we took A plus B is equal to B plus A. So here, instead of addition, we will take what? Multiplication sign. Alright. So A into B should be same as B into A. So therefore, A into B, according to the formula, should be same as B into A. So what is A? I have taken A to be 2 and B to be 3. So 2 into 3 should be same as 3 into 2. Alright. So what is 2 3s are? 6. And 3 2s are 6. So is my left hand side the same as right hand side? Yes. My left hand side is same as right hand side. So therefore closure property is valid for multiplication. Alright. So again the formula is A into B is equal to B into A. I have taken A to be 2 and B to be 3. So A into B should be same as B into A. So then 2 into 3 is equal to 3 into 2. 2 3s are 6. 3 2s are 6. So 6 is equal to 6. My answers are both the same on my left hand side as well as my right hand side. So therefore closure property is valid for multiplication. Alright. Now let us see if my closure property is valid for division as well. Now I have taken A to be 5 and B to be 6. So therefore, according to the closure property of division, it is A divided by B should be same as B divided by A. So therefore, A divided by B is what? A is 5 and B is 6. So the formula is A divided by B should be same as B divided by A. So A is 5 divided by 6 should be same as 6 divided by 5. Do you think 5 by 6 is same as 6 by 5? It is not same. So 5 by 6 is not equal to 6 by 5. So therefore division cannot be commutative. So therefore it is invalid. Commutative property is only valid for addition and multiplication, but commutative property is invalid for subtraction and division of integers. Okay. Now as we have seen, commutative property is valid for addition and multiplication, but commutative property is invalid for subtraction and division. Now, this is for integers, right? Now let us see if it is valid for rational numbers. Okay, the same formula, the same everything, only instead of integers I will take rational numbers. Let us see, children. Okay, class. Now we have seen commutative property in terms of integers. Now let us see commutative property in terms of rational numbers. Alright, so when I am talking about commutative property in terms of rational numbers are nothing but what? Numbers of the form P by Q are called as rational numbers. Alright, so we all know that commutative property is nothing but A plus B is equal to B plus A. Now, instead of A, I will take 2 by 3. 2 by 3 is a rational number and B as 5 by 3. 5 by 3 is also a rational number. So, therefore, according to the formula, A plus B should be same as B plus A. Okay? So, what is A? 2 by 3 plus 5 by 3 should be same as 5 by 3, that is B plus, as it is, what is A? 2 by 3. Okay, so my denominators are same, so add my numerator. So write denominator as it is, that is divided by 3, and 2 plus 5 is what? 7. 7 by 3, right, is equal to as it is. Again my denominators are same, so keep it as it is. Then I have to add my numerators. So 5 plus 2 is again 7 by 3. So therefore, I know that my left hand side is same as my right hand side. So therefore, commutative property of addition in rational numbers is valid. Okay, so therefore, what I got, A plus B is equal to B plus A is a commutative property of addition. Now, instead of A, I have taken 2 by 3 and B I have taken it as 5 by 3. So, A plus B should be same as B plus A. So, 2 plus 5 is nothing but 7. See, if it was unlike fraction or if it was unlike number, you have to always take the LCM. But here, as they are like fractions, I directly write my denominator as it is and directly add my numerator. But listen children, for unlike fractions you cannot take the denominator as it is, but you have to take the LCM, and I'm sure that you all have studied by now all of that, right? And if not, then I will definitely mail to me, I will definitely give you the answer. Okay, now when we're talking about subtraction of rational number. Now, subtraction of rational numbers in commutative property is nothing but A minus B is equal to B minus A. For addition, we took A plus B, right? Now, for subtraction, we take A minus B. So, therefore, we can write A minus B is equal to B minus A. So, what is A? A is 2 by 3 minus what is B? 5 by 3 is equal to what is B? 5 by 3. Minus what is A? 2 by 3. Now, okay, now my denominator is again same, so I'll write this as it is. But I will subtract my numerator. Why? Because plus 2 and minus 5, plus and minus is subtraction, right? So you have to minus and put the greater number sign. So 2 minus 5 is, or 5 minus 2 is 3. I'll write 3 as it is and put what? Positive sign or negative sign? It is a negative sign because my greater number is 5 and 5 has negative front of it. So I will put minus 3. Similarly, is equal to 3 as it is. What is 5 minus 2? 5 minus 2 is plus 3. It is not minus 3. Okay, so again I reduce it. 3 ones are 3, 3 ones are 3. So it will become minus 1 is equal to as it is. 3 ones are 3 ones are plus 1. Do you think plus 1 and minus 1 are same? No. So plus 1 is not same as minus 1 or minus 1 is not same as plus 1. So therefore, commutative property of rational numbers for subtraction is invalid. It is not valid. Okay, so subtraction commutative property is nothing but A minus B is equal to B minus A. So A is equal to 2 by 3 and B is equal to what? 5 by 3. So therefore, A minus B should be same as B minus A. So what is it? 2 by 3 minus 5 by 3 is equal to 5 by 3 minus 2 by 3. I should get my left hand side to be same as my right hand side, but I am not getting in case of subtraction, but I am only getting it in terms of addition. So therefore commutative property is valid in rational numbers for addition, but it is invalid or it cannot be closed under subtraction. Okay, now next we will see what happens when it is multiplied or it is multiplication. What happens when we multiply two rational numbers? Are they commutative? What happens when we divide two rational numbers? Are they commutative? Okay children, so in the previous session we studied about commutative property of addition and the commutative property of subtraction, right? But in this session we will study completely about commutative property of multiplication and commutative property of division. Is for rational numbers. Are rational numbers commutative for multiplication and division? Let us check out. Okay. So now we all know commutative property means A plus B is equal to B plus A. A minus B is equal to B minus A. Similarly for multiplication it should be what? A into B should be same as B into A. Correct? So this is the formula for commutative property of multiplication. Just as we have seen in integers, right? The same formula itself, but instead of integers, I will put rational numbers. Alright, so I have taken A to be 3 by 4, B to be minus 6 by 3. So according to commutative property of multiplication, A into B is equal to B into A. Correct. So my formula is A into B should be same as B into A. So what is A here? 3 by 4. So 3 by 4 multiplied by minus 6 by 3 should be same as, what is B? Minus 6 by 3 multiplied by 3 by 4. Okay. Now for multiplication, I will not take the LCM. Directly I will multiply my numerator with numerator and denominator with denominator. Alright, so what is my numerator here? 3 and minus 6. So 6 3s are 18. So minus 18. Minus 18 divided by 4 3s are 12. Minus 18 by 12 is equal to, again 6 3s are 18, but 6 has a negative sign, so it is minus 18. Minus 18 divided by 3 4s is 12. See here, my left hand side is same as my right hand side. So LHS is equal to RHS. So therefore, my commutative property for multiplication is valid. Yes? So, what is the formula of commutative property for multiplication? A into B should be same as B into A. For rational numbers, whenever there is multiplication sign, you will not take LCM, but directly multiply my numerator with numerator and denominator with denominator. So what is my A have taken it as 3 by 4 and B I have taken it as minus 6 by 3. So therefore 3 6s are 18 and 6 has a negative sign. So minus 18. See, what if my 3 also have a negative sign? So minus into minus will become plus. But plus into minus is minus. So that's why I have put a negative sign. Okay. So 3 6s are 18 or minus 18. Why? Because my 6 has a negative sign divided by 12. So same comes on my right hand side as well. So A into B is same as B into A. So therefore commutative property for multiplication of rational numbers is valid. Okay, now let us see what happens for commutative property in terms of division of rational numbers. Okay, that means what? My left hand side should be same as my right hand side, then only it is valid. If my left hand side is not same as my right hand side, then it is not valid. In this case, what happens? It is valid. Why it is valid? Because minus 18 by 12 is same as minus 18 by 12 here also. So therefore it is valid here. What happens in division? Let us check out. Alright. So I have taken, the formula is A divided by B is equal to B divided by A. Alright. Just same thing. Here we have taken into, here we have to just Take out the into sign, put the division sign. A divided by B should be same as B divided by A. Now, what is A? A is 1 by 2. So, according to the formula, A divided by B should be same as B divided by A. What is A? 1 by 2. When I divide this by what? 3 by 7. Or let me, you have studied like this, right? Let me take it like that. Okay, what is A? 1 by 2. When I divide this by B, B is what? 3 by 7. Should be same as, what is B? 3 by 7. Divided by what is A? 1 by 2. Okay. Now, you all know, whenever you are dividing two rational numbers, the second rational number will become the reciprocal of the same, right? See, now I will write 1 by 2 as it is. Division will be turned into multiplication, and 3 by 7 will become 7 by 3. For division, correct? When you are dividing two rational numbers, see, this is also having a denominator, this is also having a denominator. So, 1 by 2, first rational number I keep as it is. Division will be turned into multiplication, and 3 by 7 will become 7 by 3. Alright, so, normally I will do the multiplication. 1 7s are 7, divided by 2 3s are 6. I got 7 by 6 on my LHS. Now let me check if I get the same 7 by 6 on my RHS as well. So, is equal to, write 3 by 7 as it is. Okay. Now division will become what? Multiplication, right? Multiplication, and 1 by 2 will become 2 by 1. Remember children, again, when you are dividing two rational numbers, see, 3 by 7 is one rational number, 1 by 2 is one rational number. They both are fractions, right? They are divided by some denominator. So, first rational number will be as it is, division will be turned into multiplication, and second one, instead of 1 by 2, you will write ulta, that is opposite, 2 by 1. Alright, that is reciprocal you say. Yes. So, again, is equal to as it is, 3 2s are 6 by 7. Now you tell me, 7 by 6 is same as 6 by 7? Do you think that 7 is same as 6 and 7 is same as 6? No. 7 by 6 is not same as 6 by 7. So therefore, commutative property in terms of division of rational numbers is invalid. It is not valid. Okay? So therefore, commutative property for multiplication is valid and commutative property for division is invalid. Okay? So commutative property for addition and multiplication only are valid for rational numbers, whereas commutative property for subtraction and division are invalid for rational numbers. Okay? So today's class we have completely studied about closure property and commutative property. What is closure property? Then, yes. Thank you class, and be safe. See you in the next class, and please work out. A lot of examples are there in your textbooks as well, and if you get R.D. Sharma book, in that also you have a lot of examples. Golden book also you will have a lot of examples. But if, yes, I am definitely sure that this lockdown that many of you cannot go to bookstores and get it, but there is an online website of Sapna, so you can try getting it. If not, also you have plenty of examples on Google, so you can just Google it, try to solve as many examples, and please to write to me back if you have any doubts at dmcsonlineinquiries@gmail.com. Thank you and stay safe. See you all in the next class. Thank you.